Now I want to present about the project assignment BEJ 10403 Electric Circuit 2 with the title Second Order Circuit RLC Sinusoidal Steady State Analysis. I am Hong Peng Tat from the group 5 and my group member is Lim Yang Hui and Tiu Bun Yu. This is question 1 which is need us to solve. For question 1 part A, we use the underdamped frequency omega equal to 700 radian per second. First, for the figure 1, it shows the design circuit of the overdamped response. Figure 2, it shows the design circuit of the critical damped response. Figure 3 shows the design circuit of the underdamped response. For question 1, part B, we use the manual calculation to find the capacitor voltage Vc and the inductance current IL for the overdamped, critically damped, and the underdamped response are shown in below. For the question 1, part C, first we build the whole circuit like this. Second, we double click the step and change the step time to 0, the final value to 5. Third, change the controller current source from AC to DC. Then, we set the value of each inductance to 0.68 Henry. And also change the value of each capacitor to 3 exponential negative 6 farad. Then, set the value of the resistance is 118 ohm for the overdamped. Also, set the 238.1 ohms for the critical damps. Last, set the 315 ohm for the underdamped. Then, we set the stop time to 0.04 and run. And double click the slope. The graph above is show the capacitor voltage and the below is show the inductance current. And the gray line is for the underdamped, the gray line is for the critical, and the blue line is for the overdamped response. For question 1 part D, my answer is the response that will be give the shortest time on reaching 80% of the final value of DC is the critically damped response. The critically damped response is when the system returns to equilibrium as quick as possible without any oscillation shown in the graph, and is also same as the graph of the simulated circuit. Hence, it takes the shortest time to reach the final value no matter it is Vc or IL. After a critically damped response, which will give the shortest time to reaching 80% of the final value and following by the underdamped and overdamped response.
Question 2. The circuit in figure question 2 is operating in the sinusoidal steady state. In the slide, we can see the circuit for the question 2 and the question for the question 2. Question 2a, the first method we use are mesh analysis. By using the manual calculation, we can get mesh 1 to mesh 4, which is I1 equal to 10 ampere, I2 equal to negative 0.5592 minus J times 0.0582 ampere, I3 equal to negative 2.248 plus J times 1.306 ampere, and I4 equal to 2.165 minus J times 2.554 ampere. Based on the information above, we can get the IA, IB, and IC and the VT. IA equal to 10.378 plus J times 0.115 ampere, or we can say that 10.39 angle 0.64 degree ampere. AB equal to 1.6888 negative minus J times 1.3642 ampere, or we can say that 2.1710 angle negative 38.931 degree ampere. IC equal to negative 4.413 plus J times 3.846 ampere, or we can say that 5.854 angle 138.93 degree ampere. For VT equal to 42.733 plus J times 49.033 volt, or we can say that 65.141 angle 48.93 degree volt. For method 2 is not nodal circuit analysis. Find the nodal analysis at V1, V2, and V3. So by using the manual calculation, we will get V1 equal to negative 0.115 minus J times 10.378 volt. V2 equal to 8.444 minus J times 6.821 volt. And V3 will equal to 42.733 plus J times 49.033 volt. Hence, using the Ohm's law to calculate the voltage, the value of IA, IB, and IC. So IA we will get 10.378 plus J times 0.115 ampere, or we can say that 10.39 angle 0.64 degree ampere. IB will equal to 1.6888 minus J times 1.3642 ampere, or we can say that 2.1710 angle negative 38.93 angle negative 38.931 degree ampere. IC will equal to negative 4.413 plus J times 3.846 ampere, or we can say that 5.854 angle 138.93 degree ampere. Since the value of VT is equal to V3, so VT will equal to 42.733 plus J times 49.033 volt, or we can say that 65.041 angle 48.93 volt. Question 2b. When we are going to use the MATLAB Simulink to simulate the circuit and compare the result with the manual calculation. So at the left side is our Simulink circuit, Simulink circuit. So the result obtained from the simulation methods are not same with the result obtained by using the manual calculation, which is mesh analysis and nodal analysis. This is because the student not familiar with the operation of the MATLAB Simulink. This is question 2C is require us to plot the graph for this question. So this is the graph for the steady state current for IA. This is for IB. This is for IC, and this is the graph for VT. That's all for me. Thank you.
Analysis and discussion. For question 1, we can conclude that for the alpha greater than omega is overdamped, alpha less than omega is underdamped. Respondent circular and of the alpha is equal to the omega is critical damped. In this second order parallel RLC circuit, the Nepal frequency alpha is equal to 1 over root 2 RC. The undamped frequency omega is equal to 1 over LC. For question 2, we are using two methods to solve this problem. They are mesh analysis and nodal analysis. For the nodal analysis method, we are derive the circuit to 3 nodes. We cannot prove our results by using the MATLAB simulations. Maybe this is due to some of the energy being lost to the surrounding or the issue of the software. In this 3 current graph, we can know that IA is most higher than others. This is due to the current flow to the IA only flow to inductor only. It means the value of current is higher than IB and IC. Conclusion. In this assignment, we have tried to design circuit for overdamped, critically damped, and underdamped response. We can conclude that for the alpha greater than omega is overdamped, alpha less than omega is underdamped response circuit, and for the alpha is equal to the omega is critically damped. Secondly, we had used the nodal and mesh analysis to solve the second order circuit. We learned how to use the MATLAB software to simulate second order circuit and steady state current or voltage and plot the graph for current or voltage in AC circuit.